we can understand insulin resistance, then that's going to be the best way to fix diabetes, heart disease, fatty liver disease, and slow down cancers. Dr. Gerald Shulman. This is Tucker Goodrich. I am here with my co-host, Dr. Brian Kerley, and our recurring victim, Matt Quinn. Thank you, Matt, as always, for putting up with us and coming back to do another one of these. Brian, can you introduce yourself real quick?
Yeah, sure. I'm Dr. Brian Kerley. I'm a family medicine trained hospitalist currently, and I'm a doctor with a meme account. I'm the seed oil disrespecter.
And Matt, go ahead.
Hi, I'm Matt Quinn. I'm a established technology professional and father of two on a mission to find the truth about food and health.
Oh, that's excellent. I like that. This is a recurring series here on the podcast where I'm joined by Brian and Matt, and we go over a paper or two. We're trying to keep these topics small so that we don't get lost in the weeds. So and the last episode was a Lost in the Weeds podcast, definitely. So this time we're trying to keep it simple and cover a fairly straightforward, I hope, topic with two papers this time instead of one, but the two papers are here to give you a idea of how long this problem has been around and how long it takes medicine to figure things out. What'd you guys think?
Some piece of this I think I've heard discussed that I definitely didn't understand the mechanism or that the actual specific trials were done. And also, I think I'm right in thinking one of these papers is in humans, and I definitely understood that the thing that I think it explores that had only been demonstrated in mice, which I thought was quite interesting. But I definitely have, as always, just a bunch of questions of like things that I can't seem to see.
Brian?
I like how these papers approach, the idea of what is insulin resistance, because I think that can seem like a very tough thing to nail down. Your average person on the street and average, primary care doctor probably can't explain to you exactly what it means. They might say glucose high, insulin high, bad. But I think getting at the root of what it means and put it in a greater context is important. And I want to begin to try and do that here.
Excellent. So the topic for the week is essentially how to cause insulin resistance in humans. The first paper is titled Effects of Fat Infusion on Glucose Tolerance and Plasma Insulin Levels. And this is an old gem from 1964. And the second one is Mechanisms Underlying the Onset of Oral Lipid-Induced Skeletal Muscle Insulin Resistance in Humans. And aside from the topic of insulin resistance and glucose intolerance, both of these papers have in common a medical food called Intralipid, which is often used for people who are unable to feed themselves. Say you're unconscious and they have to put a tube down your nose and feed you directly into your gut, they will use Intralipid. Or if your gut is no longer there, they will use Intralipid as an infusion directly into your veins. So it's the primary infusion used for those two mechanisms of feeding people in the United States. A little less so outside the United States, but we will get to that. So Intralipid was invented in 1961, and by 1964, they had discovered that Intralipid causes insulin resistance and hyperglycemia, right? In humans, because they're using this to infuse humans who are unable to eat themselves, eat themselves, eat on their own. Let's rephrase that. What they did in this test is they gave them some Intralipid intravenously, and then they gave them a glucose tolerance test, and they discovered that they were effectively type 2 diabetic, right? So this has since become, and since become the standard approach. If you have some unwitting college students and you're in a medical university and you want to do an experiment on healthy people with insulin resistance, you whip out a couple bags of Intralipid and you inject it into them, and they promptly become insulin resistant. So Peter Attia, a couple of years ago, did a podcast topic of insulin resistance, and Gerald Shulman, the expert he had, is a master of using Intralipid to cause insulin resistance in college students. So we'll get into that. So what I like about these two papers is the first one is pretty simple, and it's from 1964. The second one is from 2013, right? So we're looking at an enormous gap of time, right? And it demonstrates how slowly medical science can progress. From 1964, we discovered that this intralipid infusion of soybean oil causes insulin resistance, to this 2013 paper where they start going through in detail the mechanisms by which it does so. Do you guys have any thoughts on that as we're starting to dig into this a little bit?
How much different is this from what is used today? Or
The
is it still the
Intralipid?
same? Is it basically the same thing? Because I can see it. You know, I'm going to be going back to work tomorrow, and I already know I have some patients in the ICU. They very well could have some tube feeds hanging. It's more common for us to have, the oral gastric or something tube feed. And I know there's seed oils in it. So, what is the
As
tell us
far as the
about that?
composition, I'm sure they've changed some things over the years.
Mm-hmm.
I mean, one of the things that Intralipid does pretty reliably is cause liver failure. I think some of the early lipid infusions didn't have enough choline, and so caused liver failure much more quickly. Choline is part of a phospholipid, and a choline deficient diet is how you can very quickly induce liver failure in pretty much any animal. So
So you're saying this has improved, but there are still some things that are not quite fully appreciated yet. That's the
right.
point,
So
from 63 to 2013.
right. So the basic to 2024, in fact. So the
Yeah.
basic ingredient is going to be soybean oil, medical grade soybean oil as the main calorie carrier. You're going to have some form of carbohydrate. I think dextrose is usually what they use. And then you're going to have some vitamins, some minerals, and some things like choline that are going to, provide the person with a better experience on this lipid infusion. It's the result of liver failure from this product is so common that there is actually an FDA approved treatment alternative to Intralipid. I think it's primary course of care for neonatal, or, for infants. And it's called Omegaven. It doesn't include soybean oil. It's made from fish oil. It has a much, 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 much lower level of omega-6 fats than soybean oil does, and a high level of long-chain omega-3 fats. We won't get into all of that. And if you get liver failure up to a certain point and you're switched from Intralipid to Omegaven, it will cure the liver failure. And this has been demonstrated repeatedly in humans. It's, an FDA-approved treatment. For adults, what I understand is they will put you on Intralipid until you start having liver failure, and then they will switch you over to Omegaven, which we'll skip any comments on what a strange procedure that is to go through. But at any rate.
So for everybody, there are still seed oils. There are still high omega-6 seed oils inside tube feeds in a normal hospital in the United States that we can speak of from here. But it is not the same thing as it was in 1963. But we're still figuring this stuff out, and they are here, in the the 50-year span from these two studies.
Exactly.
Yeah.
And I'm going to use the wrong word, not an analog, but something similar to this, probably a little bit, is I think is the Ensure shakes that I used to feed my
Yes.
grandparents towards the end of their lives.
Yes.
To
Very
make
good
sure
point.
to make sure that they maintained weight. And you look
Right.
up on Amazon the ingredients, and it's like sunflower oil and soybean oil and safflower oil. Like it,
And
yeah,
sugar.
I did that
It's a
20 years
donut.
ago.
It's a liquid
Yeah.
donut.
Yeah.
Yeah. Well, not even a liquid donut, because we learned from Chef Gruel that donuts are often done with beef tallow, which is why they smell so good.
Mixed with seed oils, yeah.
Yeah.
The two interesting things here. One is picking up on I think an undercurrent topic that we've kind of been discussing, but definitely discussed last time, which is that when you are looking at this, you can't, I mean, well, this isn't a searchable PDF, but you can't search for the terms sometimes linoleic acid or polyunsaturated fat or seed oils. Like those aren't mentioned here, but this is on it. This only mentions this intralipid formula, and
Right.
somewhere in there, in the range of your expertise, you understand that that is primarily like a soybean oil that they're basically shoving into these people's bodies, which I thought
Right.
was quite interesting to have found this in some ways. And then the other one was my understanding of the closest thing we have to an accurate insulin resistance test, and I might be completely wrong on this one, but I remember reading it in Ben Bickman's book, which is Why We Get Sick. He talks about your fasting insulin, or just your general insulin levels and where they should be. And so this third chart here to me was stood out, where I was like, oh, okay, so they take the intralipid, and then their insulin levels are obviously wildly higher than when they hadn't taken it, which is the insulin resistance. Their body, whatever part of their body, is more resistant to insulin. Therefore, the insulin response is like higher to try and get to tell the body you need to absorb this stuff that's in the bloodstream. I think I butchered that a little bit the way you guys are looking at me, but
No.
okay.
No, you're on it. No, it's good. Good. Yeah, let's jump in.
Yeah, I mean, insulin resistance, there's a great paper by a woman, Barbara Corky, who's one of the experts on insulin resistance and diabetes. And she basically opens up by saying, we have insulin resistance and hyperinsulinemia, and the two are obviously two sides of a coin, but it's super hard to say exactly how how they're caused, right? So they're even today, even at the forefront of medical science, there's a lot of questions about how this whole thing actually happens. There is there's a definite phenomenon where excess insulin will cause insulin resistance. Okay, that's fine, but that doesn't really answer the question, well, why do you get excess insulin in the first place, right? And this answers that question because it shows that you can give people intralipid, IV intralipid, and we'll get back to that later on, and they will promptly get that dual-sided coin of too much insulin and insulin resistance and an inability to properly process glucose, right? Which are the three primary aspects essentially of type 2 diabetes: high insulin, inability to process glucose, and resistance to insulin and its effects. And yeah, it's kind of hard, they're all parts of the whole. So I think it's somewhat counterproductive to try and wheedle out which one is causing the other one, because here we have a demonstration that something else is causing all three of them. So that makes life much simpler.
Mhm.
All right. So why is it important that we talk about soybean oil and insulin resistance in type 2 diabetes? Because, okay. So over the last century or so, the biggest single change in the human diet has been the increase in the amount of soybean oil, especially in the United States. And over that same period of time, we've had a massive increase in the rates of type 2 diabetes. So from it being an extremely rare disease to, gosh, I think depending on how you measure it, more than 50% of Americans are now considered some form of type 2 diabetic, whether it's pre-diabetes or diabetes or whatever. We're looking at a majority of the country. So that's, It might occur to people that this massive increase in soybean intake and this massive increase in type 2 diabetes could be related. It wouldn't be the craziest of ideas. So here we have 1964. Anyway, this is a pretty quick study. I'm going to pop this back off the screen. You can see this chart here. They are looking at the top, non-esterified fatty acids. These are fats that are essentially free in the circulation. Then they show the increase in glucose in the blood, which is an indicator of glucose resistance in the cells. And then down below, we have this increase in insulin. Insulin is the signal for the cells to take up glucose. The fact that insulin is high and glucose is high indicates that the cells are insulin resistant, right? And then they do a lot of speculation, which is very well informed for 1964, about why this might be happening. The finding that high levels of glucose are accompanied by equally high levels of insulin may be due to one of the three following possibilities: reduced tissue sensitivity to insulin, serum insulin antagonism, something is blocking insulin, or a block in the uptake of glucose completely independent of the effect of insulin. And what they speculate is that this is being caused by a surplus of fats, and that the cells are saying, okay, we've got all these fats, so we can't take up the glucose, and we're going to ignore the glucose symptom, which is not a bad idea, but as we've discovered since then, is not exactly what's going on either.
Well, and then they could blame that on calories, right? They could just say, well, you're
That's
eating
right.
a lot of different things. You're overwhelming your body.
Yeah,
Calories.
excess energy is how they put it nowadays, right? You've got excess energy. Okay, so let's stop that share. So then over here,
And for the record, since folks love talking about calories, I've seen plenty of low BMI type 2 diabetics with high A1C, with low A1C, with diabetic foot wounds, peripheral neuropathy, severe end organ disease associated with metabolic syndrome and type 2 diabetes. So, these are phenomena that exist outside of being obese. It's an important thing to note.
right? Okay. So here we are with the modern version of this graph. This is the 2013 paper, Mechanisms Underlying the Onset of Oral Lipid-Induced Skeletal Muscle Insulin Resistance. And we see chart A over here. And it's basically the same thing that we saw before, is you get the...
So here they're doing IV PO, so they're eating it. And then they're comparing that to I want you to take over from there.
Yeah, so they're basically, the top chart here, they're looking at effective.
Because they're comparing four things here. I want to make sure we're.
Sorry, just seen something interesting.
Yeah, so I'm sorry, I'm actually looking at the wrong graph here. I'm jumping ahead to the conclusion.
Yeah, we need to intro this paper.
Yeah, so this one is looking at IV fat, right? IV fat infusion, and you can see that insulin jumps up, and they're looking at a couple of other incretin hormones that also jump up, and so red is IV, blue is PO, which means oral, basically. I forget what that stands for. Brian will know.
Per whole.
Okay.
Eating.
So the interesting thing that they do in this study is that they note that if you give Intralipid intravenously or orally, it has a similar effect, right? You look at the insulin number here, the lines are almost the same, right? The red is the IV fat and blue is the PO fat, right? Now, in the latter two charts, C and D, those are measuring hormones that are produced in the digestive tract, right? So those are not obviously affected by the IV
Yeah.
fat because that's bypassing your digestive tract, but they go up a lot with the oral fat load. And you'll note that that hormone, GLP-1, is the hormone that is mimicked by Wegovy and what
Ozempic.
Ozempic. Yes,
Yeah,
exactly.
glucagon-like peptide 1. I hadn't seen that when I looked at this earlier. That just jumped out at me. Funny.
Right. So that's essentially part of and when things are all working correctly, that's part of the digestive process by which the body reacts to an oral fat load. Um, and then you also notice glucagon is another fat that's driven by oral intake. We have all sorts of fat sensors in both, your mouth, on your tongue, and in your stomach, and in the top part of your intestine that react to the things that are coming down and figure out how they need to be processed. So one of the long-standing questions has been, okay, one of the long-standing points has been, okay, well, we know that this intralipid does this via an infusion, but you can't therefore say that it's doing it orally. And so what this paper demonstrates is that it doesn't matter, right? You're still getting insulin resistance, and this is insulin resistant, little graph A here. This is in a fairly short period of time, right? One dose of oral intralipid is enough to induce insulin resistance.
Yes, you can't just say it's the method of delivery.
That's right. And now what's super interesting here is that they are not only looking at intralipid orally or via IV, they are comparing it to LPS. Okay, what is LPS? LPS is lipopolysaccharide, which is a component of the cell wall of gram-negative bacteria. It's something that's called endotoxin also, right? So LPS is a signal that your body recognizes that it has an infection, right? So we talked in a previous episode about danger-associated molecular patterns, DAMPs. This is the prototypical danger-associated molecular pattern.
DAMPs would be damage, and then PAMPs would be pathogen.
You're right. Thank you for correcting me. Pathogen associated, right? So essentially, the body recognizes this molecule as a bacterial infection. And this is very convenient for scientists who want to study, say, inflammation or fever, because if you have a poor little rat in a cage and you inject him with some LPS, he is immediately going to have an immune response and get a fever, right? His body sees this and says, oh my goodness, we have an infection, we have to get rid of it, even if there's no bacteria present, right? So that's really interesting because what they're suggesting here is that something that happens when the body is exposed to something like, now down here, these two graphs, they're looking at the glucose utilization under LPS, the green bars, the lipid oxidation under LPS, and they're noting that the effect of the IV and oral infusion is similar to what's happening with the LPS infusion, right? It's the LPS infusion is changing whole body insulin sensitivity, right? Now that is a fascinating observation because it suggests that something is happening here that's normal, right? Your body becomes, they've known for hundreds of years that your body becomes insulin resistant and hyperglycemic, or at least they've known for hundreds of years about hyperglycemia, that your body becomes hyperglycemic under conditions of severe infection. So for instance, if you become septic shock is a severe infection with a life-threatening immune response in your body. And one of the reactions is insulin resistance and hyperglycemia. And the thought is that happens because your white blood cells are capable of using these high levels of glucose in blood to fight off the infection, right? It's basically supercharging your white blood cells. and the white blood cells will go and convert the glucose into toxins that they can use to kill off the bacteria that are flooding your body. So there's
So
something about the soybean oil that does the exact same thing. And we'll save what that is for a future episode. But note that these people are demonstrating that it happens in humans, either via IV or via the oral route.
so to recap, an infection, LPS, which is part of the bacteria, the lipopolysaccharide, is inducing a defense mechanism in the body. And that, as what we're seeing here, is causing insulin resistance and high blood sugar. That's what people say. They're making your sugar go high because you have to fuel that immune system. And so that's what we're seeing, is we're seeing similar reactions here with an infection than we would with high PUFA.
Exactly. Right.
Hold on. Are you saying in more technical and medical language that this is like it's causing an inflammatory response? Your immune system is responding to consuming polyunsaturated fat.
That's exactly right.
Okay.
And then what I just highlighted, and I'll read it for the podcast folks, an hourly intake of oil enriched in polyunsaturated, monounsaturated, or saturated fatty acids over 12 hours increased plasma fatty acids, right, as the 1964 paper noted, starting at 8 hours after the first dose, and resulted in higher glucose infusion rates during clamps after ingestion of polyunsaturated, but not monounsaturated or saturated fatty acids after 24 hours, right? So now we're moving away from it's too much energy, too many calories in the form of fats, to this is only happening after polyunsaturated fats, right? It's not happening after saturated or monounsaturated. And in here, and then they continue, in contrast, the current study demonstrates a profound reduction of insulin sensitivity at 6 to 8 hours after a single ingestion of soybean oil rich in polyunsaturated fatty acids, which was used in order to match for the composition of the IV fat solution known to rapidly induce insulin resistance in humans. So this is a landmark paper.
It's excellent.
An absolute landmark paper. Because it's tying together the most, it's connecting the most common mechanism to induce insulin resistance in humans to the main change in the human diet that's occurred over the last 100 or so years, right? The increase in soybean oils.
When it says ingestion, does that mean this is from the bolus of somebody swallowing the oil? This isn't intravenous. Yeah.
Right.
So I highlighted this as well. I thought this was really interesting when you look at these two papers, because I've seen a conversation, and might even been a Tucker conversation, but I've seen conversations on Twitter where one side has said, oh, well, how do you induce insulin resistance? Just inject polyunsaturated fat in someone's bloodstream. And the other person has said, okay, but firstly, you're injecting that. And secondly, that happens with all fat. And I do appreciate that with a certain amount of saturated fat, you can induce like temporary insulin resistance in a certain way. I don't quite understand the mechanism of it.
Yes, that is true. There is a component of that, but one of the things that they've realized with these IV fat infusions, I mentioned that they cause liver failure pretty reliably. They have figured out that excess of any amount of fat, essentially any amount of food, will cause fat to build up in the liver, right? Think of the liver as like a medium-term fat store, okay? So what they realized in IV infusions is that you have to give the liver the correct dose. Otherwise, you will cause fatty liver very quickly just by excess calorie intake, right? And the liver converts that into the storage form of calories, which is fat. What they've since figured out is that the fat makes a big difference. So even if you're giving them the correct dose of fat, if you're giving them excess omega-6 fats, that they are going to get fatty liver. But if you switch them over to the same type of infusion of, either lower doses of omega-6 or a super low dose in Omega-Ven, the omega-3 fish oil infusion, that effect of fatty, the fatty liver goes away, right? And I mean, they've had kids, you know, there was a kid who was late stage liver failure on Intralipid as an infant, and they switched him over to Omegaven and kept him on Omegaven for years, right? The kid had basically no intestinal tract below, his stomach, and he's literally entirely dependent on Omegaven. And I think, the video I had, which was from years ago, had him at like 5 years old, and he was fine.
Sam, can you do the flush for me?
Sam knows how to help with his feeding routine at bedtime. Through a port in his chest, he receives an overnight infusion of Omegaven, providing all the nutrients he needs to live.
All right, can you hold that up for me?
Hey, I want that to be closed.
As a little kid, he was yellow from excess bilirubin in the blood from liver failure.
Since Dr. Puder's discovery 8 years ago, he's treated 200 babies with Omegaven with remarkable results.
And, now he's fine over years. So it's not just any fat. The evidence is overwhelmingly clear that the type of fat matters a lot. And that's what they saw in this study. And they go through a little bit of the mechanism here. And I don't know that we want to go too much into that at some point, but what they're talking about is we've all heard of triglycerides, right? A triglyceride is three fats attached to a glycerin backbone, and it's the standard storage form of fat. Then you have what they discuss here, a diacylglyceride, which is two fats attached to the glycerol backbone. And these are produced in the course of digestion, where the body removes a fat from the triglyceride and produces a DAG. And then ultimately you can have a monoacylglycerol, which are things like some of the endocannabinoid hormones are monoacylglycerols that are produced in the gut and throughout the body. And these act as signaling hormones, essentially, right? So they're turning a fat into a signaling molecule. And the DAGs are recognized as what induces insulin resistance in humans, but it's not all DAGs. And there's another paper, maybe we can cover at a later point, that found that it's not only DAGs containing the omega-6 fat linoleic acid, but oxidized linoleic acid was the single most effective way of triggering the onset of insulin resistance. Gee, sounds like the American diet, doesn't it?
Yeah.
This would be a good time to back up to what they mentioned at the beginning of the paper. That the idea of knockout, like removing genes with mice, is very helpful. Right there on the right side.
Yeah.
Explain to the folks what that means in terms of them mice deficient of TLR4 or CD14. So just it's important to know that these are important genetic proteins, right? They're or not necessarily proteins, but genetic determined links in the immune system.
Right.
And if you take them out, what do we see? What do we see if these are missing in mice?
Right. Yeah. Why don't you describe that?
Oh, sure. Roll back up. I'll read it.
Yep.
So what's interesting here, because what did we go over? We just went over how a immune response to a bacteria can induce insulin resistance, very similar to high polyunsaturated fat, like seed oils, intralipid, and other things. And in order to help further demonstrate this, because sometimes just phenomenon can overlap, right? You can see similar things, but this is looking under the hood. They say of note, they say deficiency of TLR4 or CD14. So these are parts of the immune system. You can get into it more nerdy if you want to. Largely protects mice from lipid-induced insulin resistance, suggesting a causal role of the CD14 TLR4 receptor complex for high fat diet and LPS-induced insulin resistance. So this isn't just two phenomena that happen in two different pathways, right? There's a similarity here,
There's a receptor that is binding to either LPS
Mhm.
or to the fats in these fat loads, and it's
Yep.
triggering the same
Yep.
immune response.
Yep.
Yeah,
So
that's a
there,
great point.
so there's these cascades that are happening because, you know, phenomenology is very important. We want to see what actually happens in the animal, what actually happens in the humans, right? But sometimes they can be two different ways, come to some endpoint. But when you remove one factor and they both fall apart, you know that that was an important part, a converging path. So that's really interesting, and that should jump out to a lot of people.
Yeah, absolutely. So, but you know, I'll play Brian's role. The simple point here is the immune receptor, the part of the immune system that detects, that's in the business of detecting bacteria, is
Yeah.
removed, and they do not become insulin resistant.
Yeah. Yep. But I don't know, maybe you're more susceptible to infection or something. I don't know.
Well, yeah,
you don't want to mess with the immune system, right?
it's like
but it proves a point.
Right. It's like corticosteroids, which
Yeah.
similarly damp down an omega-6
Yes.
pathway in the immune system. And
Good point.
one of the dangers of taking steroids is that it prevents your body's immune response, and therefore you're more prone to immune damage from infections or cancers.
Yeah. My COPD patients that I see in the hospital, they feel so much better when they're on steroids. And I have to tell every single one, almost every single time, unless they already know it, you can't live off of higher dose steroids. Even low dose over a long time is going to have some negative effects. Because, you know, steroids in a medical sense means tamp down the immune system.
Yeah. And I will note, just as an aside, that I'm legally blind in my left eye due to steroids received after a laser surgery operation.
Wow.
So yeah, steroids. Wow. I'm not a big fan of taking steroids unless it's a life-threatening situation.
I did not know that. Interesting.
Yeah.
All right,
well,
excellent. Yeah, I wanted to come back to that point because I think it's important. It jumps out. It's a good nugget.
Yeah. Yeah. No. So that's great. So Matt, thoughts, questions?
Just thinking about this immune response thing, but I think this is. I can see why you were saying that this is a monumental. I think you said monumental or
landmark.
Landmark. That's one I was going to say. Hallmark paper. Landmark paper. I think it's so it's a very clear one.
Yes.
But it's very clear. I am wondering if they wrote this kind of introduction before they got to the conclusion, because it seems like somewhere or buried in the paper is this bit that's like, oh, by the way, when it's not polyunsaturated fats, like this doesn't happen and we're totally good. But it's almost then just not referenced anywhere
That's
else
a big
in
deal.
the whole paper.
Yeah.
Which is like a significant change. Yeah.
Well, and you know, what are this does mention linolenic acid exactly once.
One word, we found it.
Nice.
Yep.
But I mean, it's all about soybean oil, so you can kind of forgive them. But yeah, it only mentions linoleic acid once. And then they do mention here, in this study, we show that myocellular membrane linoleic acid 18:2 is chemical shorthand for linoleic acid. DAG content was increased at 5 hours of lipid infusion, which reflects the 53% content of linoleic acid in the infusion. Of note, desaturation of both fatty acid moieties, meaning the two fatty acids attached to the DAG, was also found in muscles of obese insulin-resistant humans without lipid infusion, whereas others hold palmitic acid subspecies responsible. I mean, if you want to go through, again, that Peter Attia podcast and then read some of Gerald Schulman's research afterward, he initially came out very strongly saying that it was DAGs in general that caused this. And then other people started playing around with it and said, no, it's not all DAGs. And, you know, they've pretty much narrowed it down to exactly what types of DAGs. Because a DAG a diacylglyceride can have any kind of two fats attached to it, right? A saturated, an unsaturated, a monounsaturated, or two of any of those three. So there are lots of different configurations of DAGs that you can produce upon, they come in food and you can produce them from food. So figuring out which DAGs are actually causing insulin resistant was kind of key. So Shulman wrote a paper where he started going through the different DAGs and figured, oh, wow, it's polyunsaturated DAGs that do this. It's not the other ones, which is the same thing that these guys point out probably 10 years, 7 or 8 years earlier than the Shulman paper. So yes, we're definitely narrowing things down here.
And it's possible at a certain level that this could be, physiologic. It's not just strictly pathologic just because it exists. Just like how we said earlier, the reaction to LPS could be advantageous as a defense mechanism, right? But then what do we have to go full circle to the beginning? We have a population where half of the people are insulin resistant. So we very clearly are in a pathological zone right here. It's a matter of scale.
Well, and there's another great study where I think they took rabbits and they injected the rabbits with some denatured, if I remember correctly, bacteria or bacterial component. And they commented, the comment on the paper was, look, we made rabbits type 2 diabetic by injecting them with bacteria. And, the media headline was rabbits made type 2 diabetic by bacteria. But that's not actually correct. It's the body's immune response to the bacteria is to have the same reaction that we see in type 2 diabetics. And I think that's a crucial point because it suggests that type 2 diabetes is an immune response, right? Effectively an autoimmune response. And that's a crucial observation, I think.
I would love to riff on this with some immunologists one day. This would be some truly curious immunologists.
Yeah, no, absolutely. That would be a great podcast to do.
Something else I noted in this paper was, maybe it speaks to my bias. I think there's some part of that it will be, let me think, this is going to be a complex point. We mentioned energy excess earlier. I think that there probably in our corner of the internet, there is an ongoing debate around carbohydrate insulin, calories in, calories out, excess energy.
Right.
And a lot of people, I think, look at this, see a bit of this and go, you know what, I train a lot, I do eat generally in an energy deficit or calorie deficit. I think I'm going to be fine. And when I think of insulin resistance, you almost immediately start to think, and we've mentioned so, Brian, like of larger people. But on this study, the BMI range of the participants, I think is 20 to 25. I remember seeing something like that, which is like, I think I'm 21. So you're not looking.
These aren't obese people, right?
Yeah, these aren't pathologically junk food heavy people. These are fairly heavy people, fairly healthy people who pass a glucose tolerance test to be accepted into the trial, and still, some not a huge calorie change over a 24-hour period. This is just acutely happening when you put the stuff in your body. Almost the immediate response is terrible. It doesn't matter if you only eat 500 calories in the day. Like you're having a bad experience,
right?
Which I thought was a good one to call out.
Yeah, absolutely. Yeah. So anyway, so that's it. That one, I think we covered all the high points in that one. If anybody, of course, as always, I'll link to these and you can go and find them via the usual channels yourself and take a look. The first one is short and sweet, and this one is a little more long and complicated, but it really does get to, figuring out 50 years later what we've been giving to sick people for the last 50 years.
Mm-hmm. I wonder if we're causing an immune reaction in infants with the level of seed oils that we require in there. There might be something going on there.
That's good material for another podcast.
I'm interested.
We riff at the end. We riff at the end to get people excited, right?
No, I'm interested in that one. I mean, with two babies, and I would say even with the ambitious parents in our community, they think we're pretty funny with what we feed our kids.
Yeah, guys, thank you very much as always.
Good hour.
Awesome.
Okay.
See you soon.
Well, wow. We should talk.
Yeah.
Okay. I should probably turn off recording now.
Oh, I thought you were, yeah. I thought you did. I thought you clapped it off. Oh, you kept it on just in case you got some gold.